So in this next section, we get to see the first rules of counting, the first rules that help us take information, organize it in terms of sets, and then use that to count. So the first rule that we have is called the inclusion-exclusion principle. So a formula you should know. So here, n of whatever set represents the number of elements in that set. And even though we subtract out A intersect B, that's actually because it's double counted. Because remember, A intersect B is inside of A and inside of B. So when you count A, you count it. And when you count B, you count it. So you double count, so you have to subtract it once. So A union B still includes the intersection. We subtract out one count of it, though. Now, if the sets are disjoint, though, remember A intersect B is empty, and so that would be 0. So you just can add up the number of elements. Usually you should think about it before you do this. Now, this principle is very, I would say, deceptive. In other words, you can do very powerful problems with this principle. You can do very interesting problems, maybe that's a better way to say it, with this principle. So the principle itself is powerful. So what do I mean by that? Well, we'll start out with something simple, and then I'll show you a more interesting example. So for this, we got two sets, and you should always be drawing a picture when you think about this. So we got A, and we got set B. We know they overlap because 5 elements are in the intersection. So we're given lots of little pieces of information here, and we're trying to find how many things are in B. So here's my universal set, and I'm going to start counting and figuring out what's going on here. So it says, first of all, the size of the set A is 14. Now I'm not going to just write a 14 here because it's the size of the whole set. Remember, A includes the intersection, so I got to be careful. There's 28 elements in the union, so if you include both of these together, there's 28 and there's 5 in the intersection. Okay, I'm going to put that 5 there because that's the simplest place I can start. So I know that the overlap is 5 elements. Now I can start breaking this down. In set A, there's 14 total elements, but 5 of them are accounted for here, so there must be 9 in A minus the intersection. In other words, if you ignore the overlap. And now in B, we have to have enough elements that when you combine them with these 14, you get 28. So we need 14 more elements. So now notice for the union, we got 9 plus 5 plus 14. That's 28. So finally, it wants to know how many things are in B. Well, B includes this whole set. So there would be 14 plus 5, in other words, 19 elements. So n of B equals 19. Now you could use the formula itself and you could do this algebraically and it works 100%. But the picture is really useful for more complex problems, which is why I did it here. So let me show you what I mean by more complex problems. Okay, so in this piece we're given information about people applying for jobs. And so we got a bunch of responses to our ad. And some people didn't apply for any of the given positions, so people were just sending in resumes for whatever. Some people applied for all 3, etc. Now, the first question says, what was the total number of respondents? A lot of people would just add up 12 plus 10 plus 14 plus 7 plus 5. In other words, the whole first column. What's wrong about that is there's a lot of overlap. The people that applied for all 3 are getting counted multiple times. That's a way, way overcount of the number. So how can we take care of this? Well, we can essentially use an expanded version of the inclusion-exclusion principle. And so we'll use that idea that the sets overlap and we don't want to double count those overlaps. And so we can draw our own big universal set. So this is everybody that responded to the ad, whether they applied for one of the listed jobs or not. And then we could have 3 sets. This would be all the people that applied for secretary, all the people that applied for the clerical position, and then all the people that applied for the typist. Notice I made sure all 3 overlapped in the center because there were people that applied for all 3. Now, just like the previous problem, I can start breaking down the information and taking care of the overlap. So 3 people applied for none. That would be out here. They're not in any of the sets. Okay, so we took care of that. 2 applied for all 3. That would be S intersect C intersect T. That'd be this section right here. So 2 people applied for all 3. Okay. 3 applied for clerk and typist. So that'd be clerk intersect typist. So C intersect T. So that would be this right here, this whole piece. But notice we already got 2 elements in that set. And so we're saying the total is 3, so there'd be 1 more. So now the total in that little part is 3. So I can keep doing the same thing. So secretary and clerk is 5. 2 are accounted for here, so that'd be 3 left over. And secretary and typist is 7. Secretary and typist, we already got 2, so that'd be 5 more. All right. When it says 14 applied for typist, what it's saying is the size of T is 14. But we already have some of the elements in T accounted for, the 5, the 2, and the 1. So that's 7, that's 8 accounted for. That means there must be 6 that applied for typist alone. Now when you add up everything inside of T, you get the total number of elements. Same idea for clerk. 10 applied for clerk, but because of the people that apply for multiple positions, we already counted some of them. So we already accounted for 6, so there must be 4 more. And then same idea for secretary. We got 12 total. 10 are accounted for, so there'd be 2 here. Now we can start answering the questions. So A says, what was the total number of respondents? Well, that's just because we took care of the overlap, we didn't double count anywhere, we can just add up these numbers. Don't forget the ones that responded but didn't apply for the right thing. And so when we add these numbers up, we got 5 plus 9 plus 2 plus 7 plus 3, we get 26. So that would be the total. Now B said, it says how many people apply for only the typist position? Well, that'd be T by itself with no overlap. That'd be just 6 elements. How many applied for secretary but not clerk? Okay, secretary but not clerk. So you want S without any part of C. So that would be just this part of S. So secretary but not clerk. So that would be 2 plus 5, in other words, 7. And then finally, D says how many people applied for exactly one position. That would be these people out here outside of the overlaps. So that'd be 2 plus 6 plus 4. So 12 people. So it's really impressive how we can take this information and summarize it using essentially set notation. And that's the whole point, is when we can consider things in terms of sets, we can answer really complex questions regarding those situations or whatever it may be.